Welcome back. This is part 2 of our videos for chapter 5. In this video we will introduce one of the simplest loops of all, and this loop is based on counting or based on some sequence of values. It's called the for loop. And here's the example of a for loop. The control of the loop is based upon what we have on this line. And in this line we're setting up a variable that we use to count. In this instance the variable name is count. It can be any name you choose. And I'm starting counting at 1. I'm going to keep counting as long as the count is less than or equal to 10. And each time I use the variable count, I'm going to increment it again every time I repeat. So you can expect that the output will be first the number 1, then the number 2, 2 is less than or equal to 10, then the number 3, the number 4, and lastly the number 10. After 10 is used, what happens? We go here and we increment the count variable one last time, which gives it the value of 11. And at this point, this expression, count, this relational expression, count less than or equal to 10, if count is 11, then that expression is false. At that point, the loop terminates. Notice that what is being repeated? This one statement here is being repeated. You can tell that by the way things are indented. Remember the rule for an if statement. It says the if statement, the end of the if statement is determined by what comes after the right parenthesis. In this case, if there's an open brace as a new block, then the end of this construct is the close block delimiter. Otherwise, the end of this construct is the first semicolon that we see. So this is an example of a loop that does one action. Okay, why don't we take a look at what this feels like if we were to run it. Let's take a look at this. Here's the code that you see. We're going to compile it. I've already compiled it, and we're going to run it. It's going to be .f. And what do we get out? We get the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's play around just a moment. Let's make this loop count up to 20 instead of 10. So what do you think we have to do? Well, looks like we need to set the limit here, go to 20. Let's try that. Oops. And let's try to run that, see what we get. So we go to 20. What if we want to start at 5 and go to 17? Tell me what to do. We want to start at 5 and go to 17. Well, the first value of count that we want is a 5. The last value we want is a 17. And now let's go ahead and compile it and run it and see what we get. We get 5 through 17. So when you think about it, this is a very simple loop. It's based on counting. You can set where to count, what the starting value is. You can say what the ending value is, and by how much you want to increment. Let's do one last thing. Let's count by 3. Starting at 5 and going until I exceed 17. So what would I have to change? I don't change the starting point. I don't change the ending point. I change the way I count. And we say we're going to count by 3. I hope that's what I just said. So let's go back in and count by 3. So all we changed is this last part here. How do we count by 3? We want to say count equals count plus 3. I can do that two ways. I can say count plus equal 3. Or I can write the statement count equals count plus 3. So let's do this and see what we get out. And what we get is 5, 8, and 17. The number after 17 would be a 20, which is outside the range. So that's an example. Okay, see how easy that is? It's really not that hard. Okay, now let's keep going. Now, what does a for loop look like? As we've seen, it has three parts. The control of it has three components. The first is how you get started. We have to establish a variable that controls the loop, and we set its initial value. The second part is where we say the terms under which we want to continue repeating. That is a continuation test, and it's going to be typically a relational expression that causes the loop to stop when that test becomes false. But think of it as it should be the condition under which you continue. And finally, we have to specify how to change the variable that we're using for our counting. All right, so we've seen all of that. All right, so what's the sequence of things? The first thing that happens is the initialization is performed. The second step is that we evaluate the continuation condition. If it happens to be false, then the loop is over. We go to the end of the loop where that is. In this case, period. And step 3 is that we execute the body. Step 4, and pay attention to this, step 4 says automatically, after the body is executed, we update the variable and try it again. The updating of this variable occurs after the body is executed. This flowchart depicts for you how this loop works. The initialization first, the test. If it's true, you do the body, update the variable, and go back to the test. If the test is false, you exit the whole construct. Now here's an example of checking what a loop does. You can make a simple table that keeps track of all the variables involved in the loop. In this case, the control variable is really num, so we can keep track of its value. We can also keep track of what is being changed by the loop. This variable sum is being changed as we go through the loop. And finally, we can keep track of the continuation condition, whether it is true or false. So before we ever start, we have to do the declaration here that sets sum to 0. We declare a variable called num, and beforehand it doesn't have a value, it's just declared. So, what's the first step? We initialize num to 1 when the loop starts. That's here. We evaluate this expression. Num, what's the value of num? It's a 1. Is that less than or equal to 6? True. So the condition is true. What do we learn about what happens when the condition is true? When the condition is true, we go into the body of the loop. So the next thing we expect to happen is that the value of sum is updated. So what was the value of sum at the beginning? It was here. What do we do to it? We add the value of num to it, which is a 1. 1 plus 0 is a 1. All right? Remember what happens after we execute the body. Then we do the update to this variable. What variable? N. What happens to it? We increment it by 1. So after this first pass, num is a 2. All right, what happens next? We go back up to this test. We do the test. We do this part only one time. We do this part every time we attempt to execute the body of the loop. So is num less than 6? What's num? Num is now a 2. Okay? It's 2 less than 6. Num carries forward from here to here. It's less than 6, so what do? we execute the body. We take sum, which is a 1, and we add 2 to it. Sum becomes a 3, and so on. Oops, what do we do after we leave this? We always go back and update. So the next value of num is going to be a 3. And that's how we continue this. All right. Now, if the continuation condition is false the first time you hit it, the loop is skipped. The update expression typically uses some kind of updating operator such as plus plus, increment or decrement, or a plus equal, or an arithmetic compound assignment. Okay. Now here's the warning. I need to turn this red or green or something. The loop variable should never be modified inside the body of the loop, because the control of the loop variable is done here in the update. So don't change it. If you do, you will change the meaning of the loop. So I think we're going to stop here after we go and check out what happens when we take a look at the trace that we did. So this is the code that you saw. And let's just run this and see what happens. When we run it, the sum of this is 21. Now, let's take another version of this, and let's see some detail. All right, this is the same code as before, but we're adding some more detail. We're going to output what's available at each step. This is going to resemble the trace that you saw. We're going to basically output these things that you see here each time through the loop. We're going to output all this so you can see. So let's do that. Notice what we're doing. We're saying, here's the loop control, same as before. Here is what we're doing. We're updating sum, but we're printing out the value of num when we're inside the loop. We're printing out the result of this relational expression. So we should expect to see a 0 for false, 1 for true. And we're printing out the new value of the sum as we go. And when the loop ends, we're going to print out everything again. What do you expect to see? If when this is true, I continue to repeat, under what conditions do I leave this loop? I leave it whenever this becomes false. So when I print this out after the loop ends, we expect that to say false. So let's do that real quickly. And we're just going to run it. I've already compiled it. And what do we get? We're inside the loop. The continuation condition is true, and sum is 0. Then sum becomes 3. Okay, you see that number is going from 1 to 6 as we expected. When the loop ends, notice that num is 7. Notice that the end of the loop is not the last value, it's the value that goes beyond it that causes it to quit. Say that again. In order for this loop to stop, this value must get beyond 6. When it does, it stops the loop. So you would hope that at the end, the last value for num is in fact bigger than 6. It's a 7. Notice that the continuation condition, which is this, has now become false. All right. Well, that ends this segment. We have a couple more, quite a few more of these to go.